we need to find the longest subarray whose sum is 0. In this video, we will optimize the time complexity to order of n. Let's see how. So I will calculate the prefix sum of the array, and there is two cases: if prefix sum is becoming 0 or if prefix sum is repeating itself. Let's take the first case when prefix sum is becoming 0. So I will take an array 1, minus 2, 2, minus 1. I will give index to it 0, 1, 2, 3. I will calculate prefix sum of it. So at index 0, what is the prefix sum? It is 1. At index 1, what is the prefix sum? It is minus 1. At index 2, what is the prefix sum? 2, minus 1, 1. At index 3, what is the prefix sum? Minus 1 plus 1, 0. So we are getting the prefix sum 0. So this is the subarray whose sum is 0 and its length is 4. Now take the second case when prefix sum is repeating itself. So I will take 7, minus 2, 2 and 7. Let me give index to it 0, 1, 2, 3. Let me calculate the prefix sum of it. So at index 0, what is the prefix sum? It is 7. At index 1, what is the prefix sum? 7 minus 2, 5. At index 2, what is the prefix sum? 5 plus 2, 7. At index 3, what is the prefix sum? 7 plus 7, 14. So what I am seeing here, at index 0, the prefix sum is 7. And at index 2 also, the prefix sum is 7. It means no value has been added between index 1 and 2. So the length of the subarray is 2, whose sum is 0. Now let's take another input. I will take this input. So it is 15 minus 2, 15 minus 2, 2, minus 8, 1, 7, 10, 23. Now let's give index to it. So now again I will calculate the prefix sum of this array, and I will create a hash map also, and I will keep here prefix sum and the index at which prefix and its index. I will keep a max length here also, initialized to 0 initially. Okay. So initially in the hash map, I will put prefix sum of 0 at index minus 1. I will give index 0, 1, 2, 3, 4, 5, 6, 7. So what is the prefix sum at index 0? It is 15. What is the prefix sum at index 1? 15 minus 2, 13. So while calculating the prefix sum, we will put it in the hash map also. So 15 is there in the hash map? No, it's not there. So I will keep 15 and the index 0. And is 13 is there in the hash map? It's not there. I will keep 13 and its index 1. Now what is the prefix sum at index 2? It is 15. Is 15 is there in the hash map? Yes, it is there. So I will calculate the length of the array. So we will do it in array index minus hash map index. So 2 minus 0, 2. So we get the length of the subarray whose sum is 0. So I'll update the maximum length to 2. So this is the subarray whose sum is 0. So till now we get this subarray whose sum is 0. Now at index 3, what is the prefix sum? 15 minus 8 is 7. Is 7 is there in the hash map? No. So I will keep the prefix sum 7 and the index 3. Now what is the prefix sum at index 4? 7 plus 1, 8. Is 8 is there in the hash map? No. So I will keep 8 and its index 4. Now what is the prefix sum at index 5? 7 plus 8, 15. Is 15 is there in the hash map? Yes, it is there. So I will calculate the length of the array. So it is 5 minus 0. Array index minus hash map index. So I will update the maximum length to 5 since it is better than previous one, which was 2. Now what is the prefix sum at index 6? It is 15 plus 10, 25. Is 25 is there in the hash map? No. I will keep prefix sum of 25 and the index 6. What is the prefix sum at index 7? It is 25 plus 23, 48. Is 48 is there in the hash map? No. So I will keep prefix sum of 48 and index 7. So this way we will calculate the maximum length of the subarray whose sum is 0. So here 5 is the answer. Let's code it. So I will create a hash map of integer as a key and its value integer. Hash map equal to new hash map. Now I will create pf sum, prefix sum, initialize to 0 initially, then max length, initialize it to 0 initially. Now I will iterate the array from int I equal to 0, I is less than n, I plus plus. Now I will calculate the prefix sum plus equal to array of I. Now if my hash map contains this prefix sum, it will be contains key. Okay. Now then we will calculate the max length. Math dot max length I minus hashmap dot get pf sum. If hashmap doesn't contain the key, then I will put the pf sum and its index. So hashmap dot put pf sum and at which index that pf sum is, and then finally we will return the max length. Let's run it. So it's running successfully. Let's submit it and check. So test cases pass, but only 100 test cases pass. It is failing. So something is wrong here. PF sum is 0, max length. Something is wrong here. What is wrong here? So the correct output is 4 and we are getting something else, 24. So hash map is there, pf sum is there, max length is there. We are calculating the prefix sum, then we are checking, and yeah, everything looks right only. Then why it is not working? Okay, so we have not put, so initially we need to, in the hash map we need to put 0 minus 1. Since the input case, this is the first case when pf sum is coming to 0. So that's why it's not working for this test case. But for repeating, when prefix sum is repeating, on those cases it is working. So now it will work. Now again submit it. So now it's working. So this was our approach 4. Sorry, this was our approach 3, using carry forward and HashMap. And what is the time complexity? Since we are only using for loop and which is iterating from 0 to n, so it is order of n. And what is the space complexity here? Since I am using HashMap, so the space complexity will be order of n. I hope you have learned something. Thanks for watching.